Welcome to this explainer. You know, if you've ever looked at a computer, a laptop, or honestly even the smartphone in your hand right now and felt just a little bit intimidated by that magic box, well, you are exactly in the right place. Today, we're going to strip away the mystery. We're going to make all those confusing tech terms click into place for you, right here, right now. To do this, I want you to completely stop thinking of a computer as some kind of magical brain and instead start thinking of it as an information factory. It's actually a highly organized, completely predictable, and very logical place. So let's step inside. To start our tour of the factory, we really have to ask the most fundamental question. What exactly is a computer? I mean, we hear so much technical jargon thrown around, but if we just strip away the intimidation, the core concept is incredibly simple. It's just a tool. A remarkably fast tool, sure, but nothing more and nothing less. Okay, let's dive into this. At its absolute core, a computer is simply a device that takes raw data and transforms it into meaningful information. Literally, that is its entire purpose. Imagine data as your raw materials. It could be a massive pile of random numbers or just totally unorganized letters. The computer takes that raw material and processes it into a finished product, information that you can actually understand and use, like a formatted financial report or a beautiful digital photograph. And it manages to do this using 5 key traits: incredible speed, flawless accuracy, tireless diligence, meaning, it never gets bored or needs a coffee break, versatility to instantly switch from crunching math to drawing a picture, and of course, massive storage capacity. So here is our roadmap for today. First up, data to meaningful information. Second, inside the computer brain. Third, connecting with the machine. Fourth, the hidden director software. And finally, speaking the machine's language. It's a completely manageable ecosystem, I promise. Let's jump right in. Section 1, data to meaningful information. Right, so every single computer performs these 5 basic operations to move materials around our factory. First, there's input. That's accepting the raw data and instructions into the system. Next is storage, where those materials are kept safe in the memory unit until they're actually needed. Then comes processing, where the real work happens. After that is output, where the process result, your finished information, is finally produced for you. But I want you to look closely at number 5, control. This is absolutely crucial. The control unit supervises the entire flow, deciding step by step exactly how data moves between input, storage, processing, and output. Think of it as the overarching foreman of the factory floor. Moving right along to Section 2, inside the computer brain. Now, what's really interesting about this is, well, you've probably heard of a CPU, right? The central processing unit. People love to call it the brain of the computer. But for exams or just general knowledge, here is a great tip. It's literally just 2 things added together: the arithmetic logic unit, or ALU, plus the control unit, or CU. That's the whole shebang. Let's contrast those 2 halves of the brain to clear up exactly how they work together, because it's pretty neat. Think of the control unit as the manager. The manager doesn't actually do the heavy lifting. Instead, it supervises the input, the output, the processing, and the storage, basically dictating the step-by-step execution of every task. On the other side, we have the arithmetic logic unit, the ALU. This guy is the worker. The ALU is doing all the heavy mathematical lifting: addition, subtraction, multiplication, division, and it performs all the logic and comparison tasks. So simply put, the manager directs and the worker executes. Let's move to Section 3, connecting with the machine. Okay, so how do we get materials into the delivery bays? These are your input devices. You're definitely familiar with the most common one, the keyboard, which traditionally features that 104-key QWERTY layout. Then there's the mouse, which can be ball, optical, or laser-based, but we also have light pens for drawing directly on screens, touch screens, microphones for your voice, and trackballs, which are essentially upside-down stationary mice that are perfect for laptops. We also have scanners, specifically OCR, and let's bust a common myth right now. OCR does not stand for Optical Content Reader, no way. It stands strictly for Optical Character Recognition, meaning it physically recognizes printed letters and converts them into electronic text. So once the brain does its work, it needs output devices to actually show you the result. The absolute most common one is the monitor, or VDU, which comes in older CRT styles. Those are the ones that use cathode ray tubes like big, bulky old TVs, or modern LCDs that use liquid crystals to give you a nice flat panel. You also have speakers for sound, voice, and music. And then we have plotters. These are actually fascinating. They use colored pens and a literal robotic arm to draw massive blueprints and really large graphics. They come in flatbed or drum styles for handling huge paper rolls. And this brilliantly illustrates the evolution of the classic printer. On one extreme end, we have the dot matrix printer. It literally hits an ink ribbon with a printhead to form text out of tiny dots. It's cheap, it is notoriously noisy, and the quality is pretty low. We actually measure its speed in characters per second. Step up to an inkjet, and you have about 64 tiny nozzles spraying ink for much better quality. But at the top of the everyday market, we have laser printers. Super high quality, incredibly fast, and very quiet, pushing out up to 200 pages per minute. Finally, for massive industrial systems, there are super expensive line printers that can print a staggering 3,800 lines in a single minute. Section 4, the hidden director, software. So we have the factory floor, we have the managers, the workers, and the delivery bays. But right now, it's a total ghost town. It's completely silent. Why? Because without software, hardware is completely useless. It's literally just metal, plastic, and silicon sitting on a desk doing nothing. Software is defined as a set of programs that make that hardware perform specific tasks in a particular order. It is the hidden set of instructions that directs the traffic. It tells the manager what to supervise, and it tells the worker what to calculate. To understand software, you really just need to divide it into two main categories: system software and application software. System software is all about managing the hardware itself. This includes your operating system, like Windows, Unix, or Linux, which provides the basic user interface. It also includes utility tools, like your antivirus. Application software, on the other hand, is the stuff that does specific jobs for you, the user. This includes generalized packages you probably use every day, like MS Word, Excel, or Photoshop, as well as highly customized packages built for specific organizations, like a company's unique payroll system. And finally, Section 5, speaking the machine's language. So, how do we write these instructions? Well, it all comes down to a hierarchy of languages. At the very bottom, we have low-level languages. This includes pure machine language, which is quite literally just binary zeros and ones. It is entirely dependent on the specific machine's hardware, and honestly, it is the hardest thing in the world for a human to write. Just slightly above that is assembly language, which uses symbolic codes instead of zeros and ones, but it's still heavily machine-dependent. Now, bridge that gap to the other side, and we have high-level languages. These are English-like, incredibly easy for humans to read and program, and they are completely machine-independent. You've probably heard a lot of these famous acronyms without realizing what they actually stand for. BASIC stands for Beginner's All-Purpose Symbolic Instruction Code, and just as the name suggests, it's general purpose and very beginner-friendly. COBOL is the Common Business-Oriented Language, used heavily in the commercial world. FORTRAN stands for Formula Translation, which is the absolute go-to for complex scientific and mathematical problems. Then you have C, a highly structured general-purpose language, and its direct descendant C++, which is a massively popular object-oriented language today. But wait, if humans are writing in these easy, English-like high-level languages, how does the computer's brain, which remember only speaks in zeros and ones, actually understand it? Well, we need translators. A compiler and an assembler are both translators. They just start their jobs from different places. A compiler converts a high-level language directly into machine language. An assembler converts an assembly language program into machine language. They are the essential interpreters working tirelessly behind the scenes. So the crucial point here is understanding the before and after of this translation process. The actual code that the human programmer writes, whether they're typing away in a high-level language like C++ or in an assembly language, is called the source program. Once the compiler or assembler does its job and translates that human code into pure zeros and ones, the resulting machine language output is called the object program. Source goes in, object comes out, and the hardware finally gets to work. And with that, we've basically covered the entire blueprint of the factory, from raw data entering the input bays to the ALU crunching the numbers under the CU's strict supervision, all driven by the hidden software code that was compiled from high-level languages into machine-ready object programs. So I want to leave you with this final kind of wild thought. Take a look at the screen you are watching right now. Are you ready to really see the invisible factory working right in front of you? Because at this very second, lightning-fast translations from binary data into meaningful information are happening right before your eyes. Thank you so much for joining me on this explainer, and definitely keep exploring.